we first start with the definition of the heat engine and the first form of the second law of thermodynamics. The heat engine is the engine that transforms the heat into the mechanical work. In this figure is a figure of the steam locomotive or steam train. In this engine we use the heat, like we boil the water in the tank to get the steam with the high pressure and high temperature, and we use that steam as a working substance to run the turbine inside the engine, and from the motion or from the rotation of the turbine we can get the mechanical work, and eventually we can make this vehicle move. That is, we get the mechanical energy. So this is the basic principle of the heat engine. We can draw the diagram for the heat engine like in this diagram. That is, we input the heat to the engine from the high temperature or hot reservoir. This heat go to the internal energy of the heat engine, and then part of this energy transform to the mechanical work, and some part of the input energy go to the low temperature reservoir or cold reservoir. It means that we have to waste some energy to, for example, to the environment. Okay, so this is the general idea of the heat engine. You can see that what we want most is that if we input the energy of the amount QH to the heat engine, we want to convert all this energy to work without waste any energy QC to the environment. So that is the ultimate goal of the engineer who design the heat engine. We can transform all heat or the thermal internal energy that input in the form of heat from the hot reservoir to work. The question is that, is this possible? From the experience, we found that ideal engine is impossible. It means that we cannot put the energy in terms of the heat into the heat engine and convert all of this energy into the mechanical work without waste any heat into the low temperature reservoir. The engineer tried to design the engine that do this ultimate task, but so far we cannot have that kind of engine. Now in physics, we know from the microscopic description of the thermodynamic process that this process is impossible. But we will not go into the detail in that direction, but we will base on the experience of the engineer that it is impossible to construct a heat engine that operating in a cycle. This is an important keyword. Produce no effect other than the input of energy by heat from a reservoir and the performance of an equal amount of work. It means that it's impossible to build, to design the engine that convert all heat input to the mechanical work output. We call this the Kelvin Planck statement of the second law of thermodynamics. This is the Kelvin Planck statement of the second law of thermodynamics, that it is impossible to build the heat engine that convert all heat input to the mechanical work output. And this is one of the great achievements of Lord Kelvin to physics and engineering. This is the same Lord Kelvin that defined the absolute temperature scale, the Kelvin temperature scale. It is interesting to see the difference between the first law and the second law that involved with this Kelvin Planck statement of the second law of thermodynamics. One may wonder that when we study the first law and we look at for example, the isothermal process. The isothermal process that is the temperature is a constant. And if we assume that this process is happening on the ideal gas and the temperature is a constant, so the change of the internal energy is zero. It means that there is no change in the internal energy. And it means that we can have that work is equal to the heat. This minus sign, it means that if we input the heat into the system, into the gas, Q will be positive and work will be negative in the sense that the gas do work to the environment. So it means that we can convert all heat into work in this process. But the difference is that, as I mentioned earlier, that for the engine, it must be the cycle. I mean, the process must be the cycle. Or, as we have discussed before, it is a cyclic process. It means that if you start from some state, the system starts from the initial pressure, volume, and temperature, and it follows the part of the process inside the engine. At the end, it must go back to the initial state. Why we need a cyclic process? Because the engine, for the engine, we want it to work continuously. If you have the one-way process, it means that you have the start, the initial configuration, the initial state, and then go to the final state and stop. That is not what we want for the engine. The engine must do work for us. Ideally, it must do work for us forever. So it means that there is no start, there is no stop. The process that happens in the engine must be the cyclic process. That is, it must go back to the initial state and then continue doing the work, follow this cycle. Okay. So when we talk about the second form, the second law of thermodynamics in the Kelvin-Planck statement, it means that now we look at the cyclic process inside the heat engine. So it means that if we look at the cyclic process, the situation is different. We cannot convert all heat enter to the system through the mechanical work. There must be some ways that go to the low temperature reservoir or to the environment. So this is the difference between the first and the second law.